What other arrows are appropriate on this diagram, just to finish up the picture here? So Cauchy implies convergent. That was a big deal. What else? The opposite is also true. Convergent also implies Cauchy. And that, by the way, is true even in the rationals. Okay, so there's an if and only if. What else do we have? Yes, every convergent sequence is necessarily a bounded sequence. But what about the reverse? Not necessarily. Not every bounded sequence converges. Okay. What else? What other arrows do we want? Yeah, that's the thing. Because Cauchy and convergent are the same thing, that means that any arrow going into or out of one will also have to go into or out of the other. Right? So Cauchy implies bounded. Okay, what else we got?
Can we add things? Can we added Cauchy and alternating, imply convergence, and bounded and monotonic?
Okay, right. So yes, in order to get more arrows, we probably want to think about combining more than one of these criteria together. Because it's no longer the case that one of these will be sufficient for any of the others, right? But it is now possible for two of them together to be sufficient for something else. And I want to leave Cauchy out of that because now that Cauchy and convergent are actually equivalent, I don't want to clutter this up with too many extra arrows. But you said something else. Yeah. So let's get that one down for sure. So bounded and monotonic, each one of those by itself is not enough to guarantee convergence. But together, they can rule a universe as father and son, or whatever. I don't know. Right, so together, those two criteria imply convergence. Does that go the other way? No. So you can think of an example of a convergent sequence which is not both bounded and monotonic, right? Maybe it's one. In fact, it has to be one, right? It definitely has to be bounded. But you can think of examples of convergent sequences that are not monotonic, and therefore it doesn't go the other way. Okay, anything else you drew on this diagram? I mostly included alternating just to make it a nice symmetric diagram so that there are 5 nodes and 5 vertices in our graph. I think maybe also what I had in mind is that is the relationship over here. Yeah. So that's a little hard to convey on here, but yeah, monotonic implies not alternating. Right? If I have an alternating sequence, there's no way to make such a sequence strictly increasing or strictly decreasing, because it's always, each successive term bounces to the other side of 0.
But for the sake of clarification, can an alternating sequence converge?
Sure. In fact, we saw on quiz number 5, the example that you proved was actually an alternating sequence. So alternating sequences can converge, but not every alternating sequence converges.
So does alternating imply not monotonic?
Yeah, I think it does. Alternating implies not monotonic. Right, so both ways. Not alternating implies not monotonic. Oh, right, so I should have left it this way, because what you said, Ali, is just the contrapositive of the arrow that's up here. Yep. So this gives us some more tools to work with. I'm going to have you think about some counterexamples when we come back to this. We'll maybe look at some of these counterexamples and take the next step and look at how to verify some of these properties are true, how to use their definitions.